Welcome to ESTCP's series on advanced lighting controls. This module is on Luminaire level lighting controls. In this webinar, we will go over the characteristics of Luminaire level lighting controls, the operation of Luminaire level lighting controls, and we'll look at Luminaire level lighting control functionality, the components of Luminaire lighting controls, and the different types of Luminaire level lighting controls. Then we'll take a look at what are the costs of Luminaire level lighting controls, and then look at some of the non-measured benefits and health effects that are associated with Luminaire level lighting controls. Let's look at the characteristics of Luminaire level lighting controls. LLLCs are a luminaire, aka a fixture, which has a sensor embedded in each luminaire, aka the fixture. LLLCs are a type of networked lighting controls in that each luminaire is programmable and linkable. The sensors are usually factory installed, though in rare cases, the sensors are installed on the luminaires on site. Minimally, there will be an occupancy sensor and ambient light sensor installed on the luminaire. In addition, luminaires may have temperature and humidity sensors. Some luminaires will have infrared receivers, which will simplify setup and programming of the system. The figure on the left of this slide shows the basic Luminaire level lighting control. The sensor and controller are embedded in the luminaire, and as seen in the lower right, the communication is sent to each luminaire, each having a ballast or driver with a control unit, controller, and a sensor in each luminaire. The communications are further shown in the figure in the upper right, which can be done via mobile phone or laptop or desktop controls. LLLC systems have the distinction of having occupancy and photosensors in each luminaire. With sensors in each luminaire, sensing is more granular. Lights can be managed individually. This will reduce instances of overlighting and lead to more energy savings. With individual sensors, wiring between each component can be eliminated. The components of LLLC systems are sensors, a controller, and wired or wireless connectivity. The controller holds a programmable microprocessor, which may be an integral to the driver, or it may be separate, transmitting dimming signals to the drivers. Wireless connectivity is achieved via an onboard radio transmitter and receiver which connect the luminaire to an LLLC network. The system can be networked, connecting all of the luminaires and sensors to the controllers. The network can be set up wirelessly or with the use of data cable. Wireless connectivity may lend to a simpler installation. The components of the system will likely have been programmed at the factory. The programming has been set to meet current codes, usually for occupancy and lighting density. Connectivity also allows for integration of the lighting with other building systems. These include HVAC controls, window treatments, temperature, humidity, and security. The systems must be networked to accomplish these integrations. Northwest Energy Efficiency Alliance in 2021 categorized LLCs into three types of systems: Clever, which meets the Design Lights Consortium's Networked Lighting Controls Qualified Products list; The DLC researches and compiles data on lighting and controls. DLC vets and reviews lighting to make sure it meets rigorous energy and quality requirements, and lists results on its qualified products list. These systems are capable of, at minimum, dimming occupancy sensing, daylight sensing, and task tuning. Smart, which have the capabilities of clever, and in addition have data collection and analytics capability. And clever smart hybrid systems, which are clever and are capable of monitoring energy use. The Northwest Energy Efficiency Alliance, in a study from 2020, found that in a one-for-one replacement of fluorescents to luminaire level lighting control, LEDs, was 1/3 the cost of a total networked lighting control redesign. Here, we mentioned that a redesign would be the hiring of engineers and architects to do complete analysis and drawings of a new networked lighting control system. Energy savings from the one-to-one replacement were comparable to those realized from a complete redesign of networked lighting control systems. Luminaire level lighting controls saves due to direct lighting going exactly where it is desired and at the desired lumen output. Luminaire level lighting controls do have high initial capital costs, and commissioning costs may seem prohibitive to some facilities. There is flexibility in luminaire level lighting control systems. As the sensors are on the individual luminaires, the luminaires can be relocated and then programmed for their new location. Real-time reporting on occupancy and maintenance of components can be realized from monitoring the sensors. Luminaire level lighting controls can be integrated with HVAC and building management systems. Occupant-based thermal set points can be established, and this will lead to improved ventilation in response to thermal conditions. Potential for improvements in occupant safety and health is being recognized with the use of LLLC. Health facilities are finding physical assets in patients can be tracked via LLLC sensors. Real-time alerts from occupancy sensing can help to better manage ventilation. Thermal comfort management from LLLC occupancy sensors can be better tuned and more responsive than thermal management by carbon dioxide sensing. Visual comfort and sensibility can be better addressed with the granular control of luminaires as opposed to that of zonal control. Some of the advantages of LLLCs are reduced installation time, reduced design and mapping of zones. Reconfiguration is easier. Some disadvantages include the high initial cost, and smart systems may be more difficult to program. In review, LLLCs have sensors embedded in each fixture. Sensors are usually installed at the factory. LLLCs provide for more granularity of control. This control is down to the fixture level. Savings can be enhanced by placing the light at the exact spot and intensity as desired. And LLLCs are flexible, so relocation may be easier. Luminaire may be left in place and digitally rezoned. We thank you for looking at this module on luminaire level lighting controls. As a reminder, these 15-minute videos will be expanded in future modules, which are 60 minutes each. Thank you for your attention, and we look forward to you on future modules.